Properties of logarithms. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. In the previous video about the logarithmic function, we had learned the logarithms are another way of writing exponentials. So when we write the expression y equals log base b of x, we mean y is the exponent to which the base b must be raised to give x. And we write b raised to the power of y equals x. Mathematically, we say that if y equals base b of x, then base b raised to the power of y equals x. In short, y equals base b of x and base b raised to the power of y equals x are equivalent or interchangeable statements. Let's see how it works. Write an equivalent expression for the following. Being able to switch back and forth between the logarithmic form and the exponential form, it's helpful because it will allow us to simplify logarithm statements. Pay attention. Log base 2 of 8 equals 3. We can switch from logarithm form to exponential form simply writing 2 raised to the power of 3 is 8. It's helpful to notice that in both forms the base is always the same. Log base 3 of 9 equals 2. We can switch from logarithm form to exponential form simply writing 3 raised to the power of 2 is 9. 4 raised to the power of 3 is 64. We can switch from exponential form to logarithm form simply writing log base 4 of 64 is 3. 5 raised to the power of 4 is 625. We can switch from exponential form to logarithm form simply writing log base 5 of 625 is 4. Properties of logarithms. Now let's look at the properties of the logarithms. They can simplify some calculations. We obtain these properties by writing the logarithm in exponential form. Property 1. Log base b of 1 is 0, because any number raised to the power of 0 is equal to 1. Property 2. Log base b of b is 1, because we must raise b to the power of 1 to get b. In other words, the logarithm of a number that is equal to its base is just 1. Property 3. Log base b of b raised to the power of x is x, because we must raise b to the power of x to get b to the power of x. In other words, the logarithm of a power where its base is the same as the base of the log equals the exponent. Property 4. b raised to the power of log base b of x equals x. Let y equals log base b of x. Then b raised to the power of y equals x. So this statement is true. The logarithm of x in base b is the exponent you put on b to get x as a result. Let's see how to use the properties above to find the value of logarithms. Find the value of log base 3 of 1 is 0. We use the property 1. Log base 7 of 7 is 1. We use the property 2. To find the value of this expression, we use the property 4. Log base 4 of 4 raised to the power of 2 is 2, we use the property 3. Common and natural logarithm. Now we will see two important bases to the logarithms. The two most commonly used bases in math and science are 10, the base of the common logs, and e, the base of the natural logs. Common logarithms. Logarithms with base 10 are called common logarithms and are written without the 10 showing. So you write log of x for log base 10 of x. You can write common logarithm in exponential form. If log of x equals y, then 10 to the power of y equals x. Natural logarithms. Logarithms with base e are called natural logarithms and are written ln of x. So you write ln of x for log base e of x. You can write natural logarithm in exponential form. If ln of x equals y, then e to the power of y equals x. Find the value of. Let's see how the properties of logarithms work to the common natural logarithms. Log of 1 is 0, property 1. Log of 10 is 1, property 2. To find the value of this expression, we use the property 4. ln of e raised to the power of 5 is 5. We use the property 3. To solve simple logarithmic equations, we write the logarithmic equation in exponential form. Then we write both sides of the exponential equation in the same base and equate the exponents. Pay attention. Solve the following simple logarithmic equations. Log base 8 of 64 equals x. Write in exponential form. Write the exponential equation in the same base and equate the exponents. X equals 2. Write in exponential form. X equals 9. Log base x of 81 equals 4. Write in exponential form. Write both sides of the exponential equation in the same base. We see that x equals 3. Write in exponential form. Apply the property 4. Apply the property 3 and solve the equation. Log base 10 of 1000 equals x. Write in exponential form. Equate the exponents. Write in exponential form. Write in exponential form. Write in exponential form. Multiply both sides by reciprocal of 3. Apply the property 1.